Hi, in this video, we'll explore functional interfaces in Java. We'll compare them with regular interfaces, understand their features in Java 8, and then we'll dive into the usage of built-in functional interfaces like Predicate, Supplier, Consumer, and Function. So let's begin. I'm going to create a functional interface called construction bug. To qualify for functional interface, your interface should have exactly one abstract method, meaning this will allow you to use Lambda expression and method references to work with them. So let's add an abstract method. My method name is going to be paintwork. This is an abstract method. And also your abstract method needs to be one. You can have n number of static method. So I'm going to add a static method, static void all work. Since it's static method, you will have to define the implementation. So my implementation is going to be like when this method is called, it needs to print static method with the statement static method wall work in progress. So I'm going to add another method as well, which is also static, and this is going to be called as floor work. Since it's a static method, let's try to define it. I'm making use of the system println statement from the above step, and I'm going to change the wall work in progress to floor work in progress. So like I said, you can have multiple static method and default method, but your abstract method needs to be just one method. So I would not have added the abstract keyword, whether you add abstract keyword or you don't add it. By default, your method inside the functional interface is going to be a abstract method. I'm going to add a default method. So my default method is going to be like some general instruction kind of method. So my method name is general guide, and inside that I will have to add some implementation. My implementation is going to give me message like default method general instructions. So when this method is going to be used by the classes, then I want it to print me default method general instruction. So now we have our construction work functional interface ready. Also, if required, some people would wanted to add functional interface annotation. Yes, you can add it. It's not mandatory, it's optional. If you want, you can add it. So we have our abstract method, we have two static method, and we have one default method. So I have my main class. My class is called demo function, and let's see how I'm going to make use of my functional interface. So call your interface name, create a reference variable, then try to define your abstract method here using lambdas, which is going to be parenthesis. This is matching your void paintwork method anonymously, like without the name. So I want this paint method, when it is going to be called, it has to print system out.println. It should say painting work in progress. So you take your reference variable, which is construction work, and then you call your paint work method. So now when you call this method, the implementation is going to be painting work in progress implementation, because it is invoking the lambda expression which we have mentioned for our paint work method. Now, why do we have only one abstract method is? Now let's try to add one more method here, and let's see how the compiler will throw out some error, because your lambda expression will not be matching to the paintwork method, because now you have one more method. Now let's say floor work method, floor work paint. Okay. Now you have one more method that is called floor work. So the moment you add it, you see that you're getting multiple non-overriding abstract methods found in the interface construction work. Means this is no longer it is a functional interface. The moment you add a method like this, you are making it as a normal interface. So for now, let me remove that extra method and just go with functional interface, which is having single abstract method. So we have called our abstract method using our reference variable. Now let's try to call our static methods inside our functional interface. Call your static method. What you will need is you will need to use your interface name and directly your static method name. Similarly, interface name and your second static method name is wall work. And thirdly, what we have is default method. So for the default method, you will need to call the object that you have created here, which is your construction work. Then from there, you can call your general guide, which is your default method. Now let's try to run this functional interface. So we can see that our paintwork method has been called and its lambda expression has been invoked, and it is printing painting work in progress. So your static method has got called and the floor work in progress has been printed, wall work in progress has been printed, and default method as well. Now let's try to see a different context of how the functional interface has been. Now let's say I have another class called somebody wants to build a block A. So inside a block A, they are going to have a method, they have a class called block A. A, and inside the block A, they're going to have a method called build block A. So in this, what I'm going to do is I'm simply going to call my construction work interface name, create a variable, and try to define your Lambda expression as however you want. So here I'm going to put like block A in progress. So this is a completely different class, and in this class I'm trying to call the same paintwork method, and when this class it is going to call, the implementation is going to print block A in progress. Let's say similarly I have one more class called block B, and in the block B class I have build block B, and here I have a message block B in progress. So if you observe this, I have just one functional interface, and I'm trying to make use of that interface in multiple classes that I have here, and I have defined my implementation differently according to my needs in that particular classes in which I'm trying to use them. So how to call these classes inside your demo function? Let's try to call them. Try to create object for your classes, which is going to be new block A, which is new operator, which is your new operator followed by the constructor of your classes, which is block A and block B. So here it is block A, then dot call the method. Let's do that. Let's call block A, create reference variable, new operator, and block A. With your object that you created called your block A, this has to work, and try to make your methods as public here. The method needs to be public, else it will not be working in your new class where you're trying to call them. So call my functions here. Similarly, new block B object dot build block B. So the difference between this line and this line is that I would like normally have created a reference variable to point towards the object of my block A, and here I don't have that reference variable. Directly I'm creating an object dot my build block B method from my class B. And when I try to run this, I have my same functional interface trying to call them in two different classes, which is block A, block B, and the same paintwork method has been called. But in the block A class, it is printing as block A in progress, and block B it is printing as block B in progress. So this is why we have our functional interface to make use of code reusability and Lambda expressions, as well as you will be able to use method reference. So now let's try to make this interface as a normal interface. So this is your functional interface. I'm going to make them as normal interface. To do that, I'm going to introduce another abstract method, which is called brickwork. The moment I'm introducing brickwork, I have to remove the functional interface annotation, and I'm going to remove these classes that I have added, or else I'll just keep them as classes without implementation. So all these things needs to be gone. Let's keep them like this. So what we can do is now we have an interface with two abstract method, and it is also having static methods and default method. So your interface can have static method as well and default method as well in your Java 8. Previously, this was not possible. Your Java lower versions can only support abstract methods. Now we can also, now in the Java 8, it also supports static methods. So how we will be using our interface generally is either you will have to use extend keyword or you will have to use. So first, let me show how your extend keywords will work. So what I'm going to do is create another interface called additional work, and this additional work is going to extend construction work. This is one of the way how we can use my how to use your. So in this I'm going to put budget detail. I'm just having only one method in it. So this is going to be how you will be extending them. So when I'm extending them, I will be able to make use of all these methods, and additionally this new method that I have introduced in my additional work interface. So now if the block A wants to make use of my construction work interface, either I can use like implements construction work. Let's implement it. In this I'm going to put paint work, and here let me put brick work. So either I can implement the interface now in this way, I can implement it construction work, and to extend I need another interface, or I can implement the additional work interface. In this way I will be able to access all the methods that I have. Build block B budget, block B paint. Trying to add some methods in every method that has got implemented from the interface. So here for the brickwork, I'm going to add block B brickwork. So now what we have is our normal interface that has got extended into another interface, which is getting implemented in the class called block B, and also construction interface is directly implemented in block A, and additional work is getting implemented in the block B. So now Let's create objects for our block A and block B. So block A dot, call the methods that we have, brickwork, and I have block A called paintwork. I also have block A dot general guide, and I can also call block A dot construction work dot wall work, construction work dot floor work. So my static methods from the interface are directly called by the interface name itself. For the other methods that got implemented in my class, I'll have to use my object as reference. So let's also create the same for block B, which is block B equals to new operator block B. So basically I'm creating object for block B, and with my reference object variable, I'm going to call block B methods that got implemented in the block B class. So block build B and budget detail, block B dot brickwork, block B dot paintwork, block B dot general instructions. Yep, I'm stopping with this and let's try to run. So now you see your brickwork has been implemented, paintwork has been implemented, your default method has been called, which is your general guide method. Your static methods have been invoked from your interface. Similarly for block B, the block B build method has been called, then block B budget method has been called, brickwork, paint, and general. So when you see the observing the functional interface and your normal interfaces, in your normal interface, you will have to use your implement keyword or your extend keyword to make use of the methods. Whereas in functional interface, it was direct when we use a lambda expression and we never used any additional keywords. So functional interface provides more flexibility with lambdas and method reference, but they're still interfaces at their core and can also be used with implements. So that's a point that has to be noted. Your functional interface can also be implemented using your implement keyword, but that's an additional work when you don't have to do in that way. You can directly use them with lambda expression. This is just an option to also use them with an implement keyword. So from here, now let's move to inbuilt interfaces. So for the inbuilt interfaces, I'm going to start with predicate. So your predicate interface is going to give you Boolean result. So it's going to take an input and it is going to return a Boolean result. So this predicate is going to take string input, string type of data. So let's say it is going to be like is long word. So like how we defined a lambda expression, here we will be defining it. So your input is going to be, let's say it is going to be some string, and your lambda operator, whatever the string dot length, whether it is greater than 5. Now in the system out dot println, use your variable dot test it. In the test, let's say that I'm going to run lambda. Now when I run this, my predicate is returning as false because it will return me Boolean result. So your predicate takes an input and it returns a Boolean as output. Now let's also see how the supplier works. The supplier interface, what we'll do is we'll mention the output type. So our output is going to be like double. So what I want the supplier to do is I want the supplier to return me some random number. So for that, I'm mentioning my number is going to be in double type. So this is going to have a variable called random, and my lambda expression is going to be return math dot random system out dot println random dot use get method. This will be returning some value. So supplier takes nothing. If you look at it, is not taking any input, but it will simply return you value. That's why it is called a supplier. Thirdly, what you have is consumer. So for consumer, it consumes an input, but it won't return anything. So for consumer, I'm going to keep the type as string as well. So one important thing, you will have to import your java util.function.consumer, predicate, supplier, and function in order to use them. So for predicate, I have imported predicate, and for supplier, and consumer package. So let's say this interface needs to just print me a word. So what I'll do is it is going to take an input. Let's say it is going to take some variable called word, and it needs to print the word. So when supplier comes, you've already defined your system out.println. You don't have to redo that. Directly use your consumer variable dot accept method and pass the string that you want it to be printing. So here I'll put like hello world. So after consumer, what we have is function. So for function, you will have to mention the input type and the output type and the result type. So for function interface, my input is going to be integer, my result is going to be string, int2 string. Import the class java util.function class. So this expression should be, it needs to take some number as input and return string. So my return string is going to be number plus append it with the number. So for this, you will have to define a system out.println. and call your reference variable and call the apply method and pass the number that you wanted to send. So let's try to run the predicate, supplier, consumer, and functional interface. So a predicate was resulting in false, your supplier resulting in random number, your consumer is resulting in hello world, and your function interface with number 10. With that node, we are trying to complete the functional interface demonstration. So we saw a functional interface, and from the functional interface, we made our interface to become a normal interface by adding extra abstract method. And we also saw how to call your normal interface using extend and implement keyword. And finally, we saw the demonstration of predicate, supplier, and consumer and functional interface from Java 8. Try to work on the example that was demonstrated. Let me know if you have any questions in the comment section. Thanks for watching. Bye.